All right, hey everybody. So this is over our lesson 4 lab, moving molecules and solids. All right, so I'm going to open up this window for you guys just a little bit. All right, that should help you guys read a lot better. All right, so something I just wanted to head off with the beginning of our lab today is anytime we talk about a substance and the particles in that substance, if they're heated. Okay, so my question right here says, what happens to the particles in a substance when heated? Okay, and so here's my 3 bullet points that I like to think about. I like to think about what happens to the speed of the particles if they're heated. Okay, and so we know if they're heated up, the speed of our particles, they increase. Okay, if the speed of our particles increase, then I come up here and I think about what about the space between the particles? Okay, what happens to the space between the particles? The space between the particles, when it's heated, it increases as well due to the increase of speed. Okay, so they're bouncing around, they're bouncing off each other, and they get further and further apart. Okay, and then if these particles get farther apart, then the attraction between the particles become weaker. Okay, so why might that happen? Well, if we think about, I have 2 magnets here, right? And it's really hard to get them apart at first because they're so close together. But once I get them apart, I don't even feel the magnetic force between them. But as I get them closer and closer and closer together, now I'm starting to feel their magnetic attraction. Okay, so it's pretty much the same principle as 2 magnets. The closer they are, the stronger that attraction. Then the farther apart they are, the weaker that attraction. Okay, so this is what happens when we heat up a substance. Now let's look at what happens when we cool a substance. Okay, so if we cool a substance, the speed of the particles decrease, right? So the opposite would happen. And since the speed of the particles decrease, then the space, right? I have space underlined here. So the particles themselves, you guys might say they expand, they get bigger, or something like that. The particles inside of a substance, they don't actually change size. It's just the space between the particles that change size, okay? So if the speed decreases, then that means the space between the particles also decreases, okay? And if the space decreases, that means these particles are getting closer and closer together. So like these magnets, the closer we get these 2 magnets together, or the closer we get particles together, their attraction becomes stronger. All right? So that's just kind of what we've been doing in these past labs, okay? So today I gave this lab out to these guys, this molecules or motion of particles inside of a solid. I had the class pretty much do all of that stuff by themselves today, so I'm going to allow you guys to kind of go through those animations and answer the questions all on your own, okay? And this time I did attach this lab into your team, so you should just be able to edit it on Teams, and I think I'm going to do that from now on. It seems like that's the best option, so we'll start with that. And also I wanted to go over my term particles here. Okay, so when I talk about particles, I'm talking about atoms and I'm talking about molecules, okay? So if I talk about a single hydrogen atom, okay, a single hydrogen atom is, in effect, a particle, okay? And then if I'm talking about an H2O molecule, it's also a particle, okay? So an atom, a molecule, I will refer to as a particle. So there's that. So now, let me see here. This is about the time during class today that I went through this lab. I kind of talked through some of the animations and stuff with the kids. Let me see here. So you guys should be able to do that all on your own, but I'll take a look at number 7 here. So it's talking about this flexible connection point with a bridge. And so if you guys ever go to Hannibal or you guys go to West Quincy, you guys have to cross the Mississippi. Or if you guys go to like Meridosha or anyways, Beardstown or something like that, something that has a larger bridge, there's this flexible bridge or the connection. So the bridge and the road, they're not like bolted solid down to each other where they're not moving. Okay. They actually allow like a space, and they allow some space for the bridge and the road to move, to expand and contract. Okay. And so you're going to do this one at the end of your lab, obviously. But as you're answering questions throughout your lab, you should always be thinking about What's the speed of the particles doing? Right? Is it heating up? Is it cooling down? If it's speeding up, slowing down? What's the space between the particles look like? And then, what's the attraction between the particles look like? Okay. But today we're really looking at kind of what's the space between the particles look like. Okay. So try to keep that in your guys' head as you're going through this lab. All right. So then after we got done doing this lab, I'm going to take you over here to the PowerPoint. There we go. We got a PowerPoint here. And we only made it through the first 5. All right, so we start talking about what is matter. And so matter is anything. Okay, and you guys also have this PowerPoint, so I'm going to go through it fast. Oh, there you go. You guys can see it pretty well right there. Anything that, then the light goes in and out. But anyways, you guys have this. Anything that has mass and takes up space. Okay, so things like light. Okay, so like the projector here that's shining this light. This is actually not, it's not matter. Light doesn't have mass. It doesn't take up space. Gravity interacts with matter. Gravity pulls us to the earth. However, it doesn't have any mass. It doesn't take up any space. Okay, so if I actually look at this example right here, I have a cup in here, and you guys can see by this beaker that if I push it down into the water, it begins, let me see. If I push it down, it actually takes up more space, right? So this cup takes up space, so we know that it's matter. But we can also see that light is able to pass through it, and it doesn't displace the water. And gravity's pulling down on this water, but it doesn't displace it, okay? So those two things are not matter, but anything that does have mass and takes up space. Let's see here. So examples, everything around you. Air is matter, right? We can see wind, and you can blow across water, and you can see the water ripple because of it. Move on here. So mass is the amount of matter or stuff in an object. Okay, we measure this stuff in grams, kilogram. That's that metric scale we really like. We'll get more into the metric scale here. Here's a pan balance. You guys won't use that. We don't use it. We just use regular digital scales. Right, it's 2020. The mass of an object is the same everywhere in the universe, okay? So if you guys have a 50 kilogram weight here on Earth, it will also be 50 kilograms on the moon. However, if I weigh 175 pounds here, weight is different than mass, okay? So mass is how much stuff or how much particles is in a specific object, where weight is more so talking about gravity. Okay, we'll get to that here in a second. So this shows on Earth, these guys will be the same as on the moon, because just because I take this 1 kilogram weight and I take it to the moon, that doesn't mean I took any particles out, right? I didn't take any matter out of this 1 kilogram weight. This is the same weight that I had on Earth, and no matter was put in or taken out of it. All right, so now I have weight here, and where it says weight is a measure of the pull of gravity on an object's mass. Okay, so that's when I go up to the moon, and now the moon is smaller than the Earth, so I will weigh less because there's less of the moon, there's less of a planet pulling on me, therefore I'm lighter, right? Because of gravity, weight is not the same everywhere in the universe. On the moon, you would weigh less than the Earth because the moon is smaller than the Earth. So if I'm on a planet that's larger than the Earth, then I will actually weigh more because that planet would have more mass, which would then exert more gravity on me. Okay. And this is about the last slide we got to. So gravity is a force of attraction between two objects. So all objects with mass have gravity. Gravity acts like a magnet pulling objects together. So it's not only like the Earth is not only pulling on me and pulling me to the surface, but I am also pulling the Earth to me. Okay, even though I'm much, much, much less massive than the Earth, I'm still pulling the Earth to me. But since the Earth is a lot more massive than me, we feel that effect a lot more. Okay, so I hope this video helped you guys. Please let me know if you need any more help. And I'm going to go ahead and stop recording.